4.4 is simply entitled More Equations. 4.4 is a section where it takes a lot of the things that we have done across Chapter 4 and brings it all together. So you're going to have equations, some of which look a lot like the ones we were just solving at the end of 4.3, some of which look like things we solved in 4.1, but it's compiling it all into the same section of material. So we have a lot of different ways that we can solve with exponentials and with logarithms. Sometimes we have a choice, sometimes we don't. So let's take a look at some of the examples that they give us for us to take a look at. Now, one of the things that we learned in 4.2 in general was that if we have a variable that's somehow embedded in a way that I cannot solve it inside of a log or inside of an exponential, I often have to change forms. The first two examples on this slide have that happen. The first one has an x embedded inside of a log, right, inside the log itself, and the second one has the x embedded inside of the base of the log. So for both of these problems, our first step will be to rewrite using our scorpion tail, because I have to get it out of those locations where it's stuck. So there is an understood 10 here because this is a common log. It is not already written. So it's helpful at this point, I think, to write it in so that you can circle it and draw your tail around. So our 10, going to the other side, is raised to the power of 1, and this equals x minus 6. 10 to the 1, of course, is 10. And how will I solve this for x? Plus 6. So I end up with x equaling 16. When I have a log problem, I need to make sure that I didn't accidentally introduce a value that doesn't work. We call them extraneous solutions. Is it okay to put a 16 inside of here? Yes. And in particular, I'm wanting to make sure that when I try, I get something positive, and I do. 16 minus 6 is 10. That's positive. I'm good to go. So I do, in fact, have a solution, and that solution is x equals 16. Okay? So I already mentioned on number 2, I also need to rewrite this one because my base itself is the variable, and I need to draw my tail around. So x is my base. Crossing to the other side, the power is 1/4. It lands on being equal to 16. Now you can leave it written as 1/4 if you wish, or you could rewrite the 1/4 as 4th root. Either of these forms have the ability, I think, for you to be able to see that the inverse operation is to raise this to the power of 4, or 4 over 1. So if you left it in that fractional form, of course, the 1/4 times the 4 would equal 1. If you think about it in radical form, you've got a 4th root and a power of 4, which cancel out to give you just x alone. And you can grab your calculator and you can ask it, what is 16 to the power 4? It's big. What do you get? Oh, really don't want to use your calculator today, do you? Did anybody get it? You're right, 65,536. Again, you want to make sure that the value that you got makes sense to use as the base. In particular, our base down here has to be positive and not 1. Well, this is positive and it's not 1, so it works. Okay, any questions on examples 1 or 2? Okay, let's try a couple more. Or, well, one more on the next slide. All right, so there's a couple of things going on here, and we haven't solved a problem like this before. So this is new. We do have log in a couple of locations, but it's not logs on two sides, right? We've seen what happens when we have a log on both sides and we just sort of ignore the log. That's not what's going on here. I have the logs on the same side. So when I have the logs on the same side, I'm going to be able to consider those new properties that we had back in 4.3, right? The product, the quotient, potentially the power rule, depending on which I'm using. This one's addition. So what property is this? Product, quotient, or power? It's a product rule. So what the product rule said is that I can take the insides of the logs and I can multiply them. So in particular, I will rewrite this as a single log, base 2. But now I have a minus 2 over 5 times a plus 3 over 10. And it may or may not be profitable at this point for us to actually distribute and multiply that out. So I'm going to leave it in its form that it currently is and not do that just yet until I can decide whether or not I need to. Okay, is that rewriting step okay? Okay. At this point, aside from the fact that it looks really messy inside the parentheses, it's really no different than 1 or 2. I have log on one side, I have a number on the other side, and right now the x, or in this case a, is embedded inside of those parentheses and I got to get it out, which means I have to change it into an exponential form by using my scorpion tail. So I'm going to circle my base 2 and I'm going to draw my tail around. This says 2 to the power of 0 equals a minus 2 over 5. In fact, if you wish, you could actually multiply at least the denominators together. It's the factoring of the numerators that I would like to preserve in case I need it. A minus 2 and a plus 3. And we can leave the denominator then as a 50. Now let's be honest, that looks better, doesn't it? It does. It looks more familiar. It looks like stuff we did in chapter 3, actually. Now, do you remember what 2 to the 0 power is? 1 is right. So I have 1 equals, I'm going to still leave this as a minus 2 times a plus 3 for the moment, over 50. Any thought about what I might want to do next?
Multiply by 50?
Yes, we want to multiply by 50. And pretty soon we are going to have to multiply that numerator out. So I have 50 on the left, and it equals a minus 2 times a plus 3. Now, if it happened that I had it as 0 on the left at this point, I would be able to set pieces equal to 0 and solve, and I would be very glad that I never multiplied it out, because it would still be in factored form. But if I have anything but a 0 on the other side, I do have to distribute it, multiply it all out, and recollect all my terms, because this is now a quadratic equation. So we're going to take this, and we're going to multiply it out. So I have 50 on the left. I have a squared. My inner term is negative 2a, and my outer term is positive 3a. So that's a positive a. And then my negative 2 times my 3 is negative 6. Quadratics always have to be set equal to 0. So what do I need to do with the 50? Move it, subtract it. Yeah, I need to move this 50 onto the other side. So this is 0 equals a squared plus a minus, and then negative 6 and negative 50 is negative 56. Now it sort of feels like I'm, recreating the wheel a little bit because I'm going to factor, whereas I just distributed a moment ago, but the value's different, right? It's a negative 56 now instead of the negative 6. So as I factor this, I won't get the same factors as before. I have a and a. The negative 56 at the end means one's negative and one's positive. I need two numbers that multiply to 56, but their difference is 1.
7 and
7 and 8 will do it. Do you know which one I need to be positive, Will?
8. 8.
Yep. I need my 8 to be positive and my 7 to be negative. And I do that because I need to get that negative a in the middle here. Or I'm sorry, that positive a in the middle here. All right, awesome. This is still equal to 0. So I set each factor equal to 0. A minus 7 is 0. A plus 8 is 0. So if I subtract and I add, of course, respectively, this is a is 7 and a is negative 8. but I have to check it back in the original work to make sure that the insides of the logs are positive, right? So if I put a 7 in, and we'll do it into each of the interiors here, a 7 in here, 7 minus 2 is 5, and 5 divided by 5 is positive, right? Over here, 7 plus 3 is 10, and 10 divided by 10 is positive. All good to go? Yes, definitely. Okay, let's try another one. Let's do same value, negative 8 rather. So I put negative 8 minus 2 is negative 10, and negative 10 divided by 5 is negative. Negative 8 doesn't work. Negative 8 is an extraneous solution. So there's only one solution to my problem. A is 7. Any questions on that? Let me make one comment since nobody asked about it, because it is a little bit weird here. What you might notice is that when I add these two things together and I get 0, that seems a little funny. How do I add two values and I get back 0, right? Well, the reality is that one of those values, one of those logs, log base 2 of a number could be negative. Even though the inside can't be negative, the whole expression itself can. That's a little different than what we're used to with some of our other properties of different, operations. But it does work here, and it is okay. Okay, let's try another one. So, without any guidance, what do you think you might want to do first?
Rewrite it
How?
with the quotient rule.
Excellent. So Jake noticed, I didn't mean for that one, I meant to be highlighter. Jake noticed there's a negative here, right? And he's exactly right. That means there's a quotient rule at play. So good observation. We will have log base 4, and then I have the first value x divided by the second value x plus 2. Great first step. What might we do next? Yes, you're exactly right. So Caleb tells me I'm going to do the scorpion tail. So I'm going to circle my 4, and I'm going to draw my arrow around. That makes sense because the x is embedded inside of a log, and I got to get it out. So yeah, I will have 4 raised to the power 2 equals x over x plus 2. At this point, it becomes a chapter 3 type problem. And this one I have a rational expression right now because I have the fraction on the left, or on the right. What is 4 squared? 16. And I have x over x plus 2. What could I do next?
Multiply x plus 2.
Yeah, I can multiply by x plus 2. Or if you think about 16 as being 16 over 1, you could think about it as being cross multiplication. So on the right side, the x plus 2's cancel, which was the whole point, leaving me with x. And on the left side, I need to distribute the 16. So I have 16x plus 32. Now what?
Subtract 32.
We could subtract the 32. I think it might be easier to subtract the 16x because the x is already on the other side. But yeah, we're going to collect like terms in some fashion, right? We need to move things around so that the x's are on one side, the constants are on the other. So what is x minus 16x? Negative 15x. Now what? Yep, divide by negative 15. So x is equal to, well, it's equal to negative 32 over 15. Let me get a decimal for it. So it's approximately negative 2.1. Wow, this should say 333, not a space. Okay, always we check to make sure that it works back in the original problem. It's easier, at least visually, to check to make sure the representation that's a decimal here makes sense. So that's why I wrote it that way for the moment. Will this work in my original problem? No, it won't. It fails right here to be able to be put in. It actually fails here too. I can't plug this in and it works. It just doesn't. And it was the only choice that I had, right? So what does that mean my answer is? This is extraneous. That's true. But what does it mean my value is for my actual solution? Yeah, it means there's no solution. The only one that was a viable option ended up being extraneous. There are no more choices, which means there's no solution or no solutions. Better solution. So that can happen. You can have no solution. Let's do number 5. Okay, so this looks a little bit like a couple things that we've seen. I do have a log on both sides, but I also have this random 1 plus beside one of my logs. Y'all see that? So if I do not have the ability to have a log, a single log with nothing else added to it on both sides, what it means is I need to move the logs onto the same side. So I'm going to leave the one that's there on the right, and I'm going to move the log that's on the right to the left. Since it's added, I can subtract. So minus log of x minus 1. So just rewriting, this would be log 4 minus log of x minus 1 equals 1. Does that make sense? That actually makes it look a lot like this problem. So a lot of times your goal is to make it look like something you've seen before. Because if I can make it look like this, I know what to do. I've done one now. I can do the same process again. So what would my next step be now that I have the logs combined on this, or logs on the same side? Right, we'll use the quotient rule. Log of 4 divided by x minus 1, and it equals 1. Then what? Scorpion tail. What's my base, Cole?
10.
It is. There's an understood base 10 here. It is the common log, and we'll draw our scorpion tail around. So this time I have 10 to the 1 equals 4 over, x minus 1. 10 to the 1, of course, is 10, equals 4 over x minus 1. What would I do then?
Multiply by x minus 1.
We'll multiply by the denominator x minus 1. Of course, the point in doing so is so it cancels on the right, leaving me with 4. I'll distribute the 10 through on the left. So I have 10x minus 10. Now what? Add 10. So I have 10x on the left, I have 14 on the right, and divide by 10. You can't leave it 14 over 10. You either need to simplify the fraction, which would give you 7 over 5, or this one is actually a very nice decimal, precise and exact. That's what? 1.4. So either of those versions would be acceptable ways to write the final answer. They're both exact. We do need to make sure that it actually works, right? So I'll take the decimal representation because it's a little easier to think about. 1.4, the only x is right here. Is 1.4 minus 1 going to work? Yep, it is. Remember, just need it to be positive, and it is, so we're good. So this is my solution, one or the other of them. Okay. One more example and we're done for today. Okay? Number 6. Actually looks a lot like 4 and this point on 5. Right? So what will I do on 6?
Condense it.
Yeah, I'll condense it. This time, though, it's not a quotient rule, it's a product rule, right? So I have log base 3 of x times 1 over x. And it equals 0. What is x times 1 over x? No, it's 1. Yeah. What do you notice at this point? What's that? We can do one more thing, but what do you notice that makes you think that, Cameron?
Just 'cause it was
Okay, we've always gotten the equal to. There's something else going on.
It's one of our properties.
It is one of our properties, but not quite written just the way I want it just yet. What is our goal anytime we're working these problems? To solve for x. What do you notice at this point? There's no x. Do you guys see that? So there's one of two things that happens at this point. It's either no solution if the statement that I've got right here is false. If the statement right here is a false statement, there is no solution. Or it's infinitely many solutions if it's a true statement. And the reason I say infinitely many and not like all solution is because I do have restrictions here, right? X can't be just anything. There are inputs that I cannot have inside of a log, and I have to be respectful of that regardless of what happens at this point. So what I need to decide is whether or not this statement is true. So if you don't recognize, Cole mentioned it's one of our properties, and it is one of our properties, but if you don't happen to recognize that right away and you think about your scorpion tail, you'll get it real quick. This, if I rewrite it with my scorpion tail, says 3 to the 0 equals 1. Does 3 to the 0 equal 1? Yes, it does. This is true. And since it's true, what that means is that I have all x values that are allowed to be put inside of my logs. So what values am I allowed to put inside of my logs?
positive.
Positives, right? And it doesn't matter whether or not I look at the first log or the second log. I need to make sure it works for both of them. But it's the same for both of them in this case. So my x values are simply anything that's positive. And that happened because my x's were eliminated along the way. And the statement was still true. If they were eliminated along the way, like let's say, for instance, that this had not been a 0 over here, and it instead had started out as a 3 or something else, it doesn't really even matter, but anything else. If that had happened and we got to the end of the problem, it wouldn't be true. I would have ended up with 3 cubed equals 1, and the answer would be no, it doesn't. And the answer then would be no solution. Does that make sense? Excellent. So 4.3 and 4.4 are due when you guys come a week from now. Okay, so 2 sections for a week. Not too bad. Enjoy your Thursday off, and I'll see you guys in a week. We will have a quiz as well on that day when we come. Quiz and review on Tuesday, the 27th, I think it is. I think.